Welcome to the story of the beginning of everything. I've dedicated this book to all those that are a part of me, an autobiography by the Protoverse, assisted by his Snapchat story. Once upon a time, there was no time or space. Then, at time zero, there was a protoverse. Key word. Where have you seen the word pro in a word? And what does it mean? The protoverse was very small, no bigger than a pinhead, was made of pure energy, and he was extremely dense and incredibly hot. Another key word. Have you heard someone use the word dense before? What do you think it means? Activity time, role play. Using marbles or a student volunteered to demonstrate the concept of density using different contained spaces. Or ask your lab tech for the density cube set. Time, within the first second. The protoverse decided that he wanted to explore, so he began to expand. And now currently, his size was of a rock melon. As he increased in size, he also decreased in density. So he began to cool down. Key word. What is surface area? How do you measure surface area of an object? I'll give you a hint. Think about wrapping paper and how you wrap presents. How do you naturally change your surface area when you're in different temperatures? And why do you think you do this? Think about in winter or summer and how you position your body or what clothes you wear. I'll give you a hint. It's all about heat loss and gain. Another activity, a student-assisted demo. Using 2 cooked hot potatoes to test if density affects heat transfer, so the way that heat moves, and in this case is lost. First, begin by measuring the starting temperatures of both potatoes. Then, mash one potato on a plate and spread it out evenly. The other will be left as a whole. Place both these potatoes in the same position in the classroom. Leave them for 5 minutes. During this time, it is suggested that students create a hypothesis based on their understanding of density. After the 5 minutes, record the temperature again and note the differences. I wonder which one will have lost more heat quickly. The potato that was more dense or the potato that was less dense. So now we're still within the first 1 second. And as the protoverse continued to cool down, he witnessed 2 incredible things that started to happen. The first being that the forces that we felt today were created: gravity and electromagnetic radiation. Can you see Mr. Gravity and Mr. EM? The second was that his energy began to turn into matter. What is matter? Or what's the matter with you? It would be rude of me not to introduce you to the matter. We've got electrons who are negatively charged. We have up quarks, and we know that they're up quarks because they have thumbs up. We have photons, who, if you can see in the picture, might be assisting with light. We have down quarks, you guessed it, because they have down thumbs. I want you just to picture all of these type of matter, that all matter and these particles are moving all of the time, and sometimes they collide. Key word. Where have you heard collide, and what do you think it means? Now we're up to 3 seconds. And guess what? The protoverse is the size of a soccer ball. Now we know this story continues to expand and cool down. And you know how some people can bear the heat more than others? Well, it's the same for particles. This is the part of the story where we find out who loves summer. As particles collide, so we know that means to come together and smash into one another, those that don't mind the heat start to make friends by bonding. Now, whenever you see that lightning mark, that means that they've started to bond and made friends. So now, once once the particles start to collide, this is where we start to see the brain of an atom created. So hopefully you can see up the top of the left-hand page that we have an up quark and a down quark. Now remember that you can tell by an up quark and a down quark by their thumbs. Okay? So what's happening with that lightning bolt? That's right, they're colliding. And so when they collide, they come together. And now you can see that it almost looks like an Ultra Ball, the thing from Pokemon. And you can see that one of the photons is just watching an aura. Now, you might notice that next to the Pokemon looking ball, which is the up quark and the down quark together, is that there's a purple and a blue arrow. If you follow them to the right hand side of the page, you'll notice that they form protons and neutrons. Now, I'm not sure if you remember from our previous page when we first met all of the matter, but the electrons were missing an I, and they were negative. Can you see, by looking at the diagram, what charge a proton is? That's right, it's positive. P for positive. And what can you see is the neutron? That's it. It's neutral. It's got an equal sign for its lips. Now, this might be a little bit hard to see in the diagram, so you might need to look at the props. However, the neutron is more of a blue-purple color and the proton is more of a purple. Now, I'm not sure how much you know about mixing colors with art, but if you add more blue with red, you'll get more of a blue color. If you add more red, then you'll get more of a purple color. So in fact, the neutron is made up of 2 blues and 1 red, and the proton is made up of 2 reds and 1 blue. Who would have thought you would have been talking about art in science? Okay, so now that we've got that all clear, now we've got protons and neutrons. And we've still got those photons down the very bottom with their light bulbs across their head. And I'm not sure if you can see their hashtag, but it says that hashtag cool by association. So while this is all happening, they're just watching. So now that the proton and the neutron are formed, you can see that there's another lightning bolt. And what they're doing is they're colliding and they're bonding together. So hopefully you can see if you follow the other blue arrow that's on the very last side of the right-hand page, that then they hang out and they start to be friends, and we call them the nucleus. Now, the nucleus we probably won't talk about for a little while, but that's actually the brain of an atom. And an atom is just a fancy word for all types of particles. So everything that you know is an atom. It's made up of atoms. And inside that atom, it has a brain called the nucleus, which you now know is made up of a proton and a neutron. These key words will come with time. All we want you to focus on right now is just what they look like. Okay? Now, because the photons have been watching and they kind of want to be cool, so they, at this stage, decide that they want to hang out with the nucleus. Okay? They're not bonded, but they're just kind of hanging out. All right? And that's what that hashtag squad is about. So that's the nucleus, which is made up of the neutrons and the protons, and then we just got the photons just hanging out. Now, I know this might be really hard for you to think of because we're just up to 3 seconds of the story, but now we have to fast forward to 300,000 years. You haven't even lived that long. All right, so now that it's cooled down, hopefully you can see that our protoverse is hanging out like a snowman now. It's not that cold, it's just to demonstrate the concept. But now that it's cooled down and there is more universe to discover, the photons, because they've been with the nucleus for a long time, 3 seconds to 300,000 years, they're pretty good friends now and they think that it's time for them to move on. So the photons say goodbye to their friends, the nucleus. And as they do that, they need to see where they're going. So they shine light across the universe and they give light to what we call is the light era. Oh, did I forget to mention that it was dark previous to this? Whoops. So once the photons have left, because remember they're off to discover, The electrons can actually see what's around them. Only with their one eye, because remember they're negative in eye, and that's why they have a negative charge. The electrons can see just how lonely the nuclei are. And now that it wasn't so hot because it's cooled down, they really don't mind rotating around them. Ooh, that's a stable atom. So we've got another key word, and if you were listening, you would know. What is an atom? Where have you heard it before? And what is an atom in relation to us? Hopefully you've got them. Now the first 3 atoms to be created, so remember, they're building blocks. And that's the nucleus, which has got our proton and our neutron, which is our blue and red big balls that are in the middle of that diagram. With the electrons, the guys with one eye, they kind of remind me of the minions. And they're rotating around the nucleus to keep it company. The first 3, combinations of that to happen are these first 3 atoms that we're looking at here. First one is called hydrogen, the next one is helium, and the third one is lithium. Now, if any of you have seen a periodic table, you'll know that they're the first 3 elements. Element, I guess, is just another fancy word for an atom. And remember, atom is another fancy word for a particle. So I guess we can say that they're the first 3 particles that we can find on a periodic table. But you'll have plenty of time to learn about that later. Oh gosh, we have to do it again. So we went from 3 seconds to 300,000 years, and now we're fast forwarding even further to 300,000 million years. So you remember Mr. Gravity from when we were talking about the forces? He was hanging out with Mr. EM. Well, Mr. Gravity believes that it's now his time in the universe. It's his time that the universe knows his name. He's sick of just living in the shadows. And so what he does, he's similar to, a cowboy, and he begins to round up the hydrogen, helium, and the lithium. So then they get closer and closer together. Okay, and they start to form these things called a dust cloud. And now I'm going to prompt you here. So what do you think is going to happen to their density? Who can remember what density is? And if you think you know what's going to happen to its density, I want you to start thinking about what you think is going to happen to its temperature. Oh my God, you got it right. It means it's going to get denser and it's going to get hotter. And guess what? And this is how stars are born. You know? So they're hashtag I love gravity all the way. So Mr. Gravity is the reason why we have stars. Because he rounds up those 3 atoms, those 3 particles. Can anybody remember what they're called? Yep, you got it. Hydrogen, helium, and lithium. And they round them up and they get them to closer and closer together, which means that in a smaller space, those particles, those atoms, they're closer together. And when anybody is always closer together, they get hotter. So I just want you to think about if you're in an elevator, the more and more people that get crammed into one elevator, the hotter you're going to be because the denser that elevator is. Because dense just means when it's increasing in density, it just means that there's more particles or more things in the same space. Okay? Now, I can hear you asking me, yeah, great, miss, but where do I fit into this story? Now, I want you to all put your thinking caps on. I don't know if you know what that diagram is, but I used to watch that when I was a little kid a lot. They're the Chickmunks, which used to be a cartoon. Now, Dave there, you might see he's got like a pretty white cap with like a red ribbon on it underneath his green visor. Well, Simon there, he actually made him a thinking cap because he was frustrated that they weren't as interested or weren't as good as understanding the things that he wanted to talk about. So he made them a thinking cap and then entered them into this smart competition. So that's what I always think of when I think of thinking caps. Anyway, everything that exists in this universe was created at the very start of our story. So I want you to think if everything that exists now exists then, everything has to be recycled, including us. And if you only take one message away from this story today, it's that each and every one of you are extremely special and are very capable of shining bright, just like these stars. Because in fact, when a star undergoes a supernova, which unfortunately is when a star comes to the end of its lifespan and it kind of explodes, all of its contents, its dust and its atoms, get caught up in the gravitational force of another star. So we can see that Mr. Gravity is there again, and he's pulling around the dust and all the collateral damage, I guess, from the supernova from the past star. And this is how galaxies are formed. So the stardust is collected in this gravitational pull that Mr. Gravity is creating around a new star. And then all of the rocks and the dust, they start to collide together. And that's when they start to form the moons, the planets, and us. So we are, in fact, stardust. And did I mention that you're 13.7 billion years old? This story is only the very beginning of where we're going in our 2-year journey. So I hope that you enjoyed this story and that you continue to ask questions wherever you go and bring your curiosity. Now, it's your time to work with your classmates in a way that your teacher is letting you, has instructed you to create the story of the beginning of everything. So this story that you just read, you now have to use the models that you've seen in this picture book to recreate what you've just read. I hope that you enjoyed the beginning of everything. Have fun. We'll see you next time.